Hello all, Aditya Shastri here, and this is a part of an assignment of a project which is machine learning using Python. So we are going with an example here called as Boston housing. It's an example for price prediction of houses in a city called as Boston. For this, there are different steps, number of steps to do this. So first step is that is we'll find the attributes with maximum correlation to the price. We'll split that data into training and testing, and after that choosing a linear regression model. For that we'll train that model and arrive at an with the slope and intercepts, and finally we'll predict prices from testing data. So this is our program. First of all, we will import some libraries, functions and datasets which are required for our this, and this Boston housing dataset data is already present in Python. We just need to import it. So first step is here we have imported NumPy. NumPy is a library used to handle multi-dimensional arrays. It provides an easy way to perform vectorized operations. So we are using NumPy as NP here. After that is Pandas. Pandas is an again open source license library which provides high performance and easy to use data structures, and it's data analysis tools for Python. Here we will use Pandas to load data into data frame object. This matplotlib is used to draw graphs. It's an 2D plotting library which produces publication quality figures in a variety of hardcopy formats and interactive environments across platforms. And this PLT is a object which is used to draw graphs. Next step is we have imported funk animation here. This funk animation generates animations, so it helps to visualize. After that, this sklearn library, it is a free software machine learning library for Python, and it provides many machine learning algorithms out of the box. It provides modules for many common tasks such as loading dataset, splitting dataset, pre-processing, etc. So we are importing this Boston dataset from sklearn, and then we are importing mean squared error from sklearn pre-processing. This one mean max scalar from pre-processing. And what else? Importing train test split function from sklearn model selection. So what it does is this function takes data set as features and targets and splits them into two sets, training and testing. Here we have imported HTML from IPython library. It is used to display result on the screen. So here is our first step. We are loading the dataset with the load Boston function and storing it in a variable called as Boston. So after loading, this dataset is loaded. features equal to pd.dataframe. What here we have done is we have stored the features from dataset into pandas data frame called as features. Data to be stored comes from bootstrap.data and name of the columns from bootstrap.feature_names. This one prints feature data frame. So after loading this bootstrap dataset, using this command we can separately display a column separately. Here we have displayed age column using print function. We have stored the target column into another data frame called as target, and target column of the dataset is also stored as a property of the object with the name target. So we can see here different columns, 506 rows are there in this dataset and 13 columns nearly. These are different attributes of dataset. See here 506 rows and 13 columns. So this is one that separate age column. Only age column is displayed, and this one is again print target column is a separate. Again we have done this printed here. So what we have done is we have find this minimum and maximum values of only target column. In the target column which is the minimum value and which is the maximum value. So 5 and 50 are there. Then concatenating features and target in a single data frame. So here we have concatenated features and target data frame, and this x is equal to 1. This concatenates data frames along columns, so one data frame beside each other. Okay. So we can see concatenated, this target is concatenated with features, attributes, other. Same here. Next step is we are finding correlation between all attribute and target. So what is correlation? Correlation describes how closely the values in one column are dependent on values on other column. So we are finding correlation between all attributes and target. Here we have find absolute value, finding absolute value of correlation between each attribute and the target. You can see here next step is zip function is used as a list. Zip function takes multiple lists and returns a list of tuple in which each element is a tuple of nth value in each list, making a list of pairs consisting of pairs of correlation value with the label for respective attribute using a zip function. This one. So obtained list is sorted in descending order, sorting pairs to obtain all correlation values in descending order. Also you can see lambda function is used here. Lambda function is used to extract the key for sorting. Since we want value in descending order, we have set this reverse parameter to true. What are you saying, man? Okay, so lambda function we are talking about. Lambda function here is used to extract the key for sorting. Since we want values in descending order, we have set this reverse parameter to true. So for displaying the chart, we have these steps. And in this, we are plotting the bar chart showing correlation. So it generates a list of indices that in a range equal to length of number of attributes. So this will generate a bar graph dot bar. PLT means it will plot, and this one is for bar. It takes parameters such as index, correlation, width of our bar, and G means green color for color. Labeling is done for x-axis and y-axis. On axis we are having attributes, and on y-axis we have correlation values. After that, this x-tix is a function. It sets the label for each bar by passing the index and labels as arguments so that we can identify which bar corresponds to which feature. This code will show output. So this is the descent bar graph. We can see from graph we can see that higher is the correlation. They are related to target values. Elstat attribute is mostly maximum, and it's correlated to target value. Second most correlated value is this RM. Moving to next step is normalization of data. X variable will contain Elstat values, and Y will contain target values. Min-max scalar function is used here. It provides inverse transform to compute minimum, maximum transform values and returns normalized values. This reshape function value is used as a parameter to fit transform method and get normalized values and store it in variable called as x. Similar to x, scale, reshape, we normalize target values. It's done here. So here step 1 is completed. Next step is splitting of our data into training and testing data. sklearn library we have in Python. It provides function called as train test split. This parameter to this function are dataset and a fraction of dataset to be considered for testing dataset. Dataset given in two parts, features and target. 0.2 here indicate that 20% of data is randomly sampled as a testing data. Next is we have defined mean square error to calculate error between actual and predicted values. It's true values and predicted values. We have computed the error here. First store size of attribute values, then we use equation to compute error and return the error. Next is the update function. This update function is used to update weights such that weights gets closer to the final value. Update to the weights is computed by taking gradient at current position with parameters to this function are current slope, this attribute value x, target value t, learning rate and intercept c. This function returns m and c updated one. Okay, you can observe here that we have multiplied learning rate here, as learning rate controls how much the weight changes. That's all. Okay. Next is we have defined gradient descent function. This gradient descent function is used to minimize the error with each iteration until a minimum value of error is obtained. Gradient descent function takes parameters initial estimate of slope m, initial estimate of intercept c. Here x is numpy array of values of independent variable, t is a target variable, and learning it. So first we have initialized m and c variables, the error values list in the mc value list. And then we enter loop, for loop here, until number of iterations is reached. We will compute it and store error for current values of weights. Check if error has gone below threshold, and if error is less than threshold, then break from the loop to stop further training. Then we append the error to the array error values. We have updated the weights using update function. You can see here, append the updated weights to the list m and c values, and after coming out of the loop, return the final values of m, c and error values. So after defining it, we are calling this gradient descent function with setting values for m, c, learning it and iterations and error threshold. We have set initial values of these values like learning rate, iterations. After that we are calling the gradient descent with the correct order. This is the order. Then we will plot regression curve. This regression line plot is onto training data. Training data is represented as scatter, as it shows how training data is distributed. Parameters to this function are x, y coordinate for each point. So here we have to generate the predicted y values for the corresponding x value using m and c. Displayed plot shows that training data does not lie on straight line. Here we can see displayed plot does not lie on straight line, and line that model has predicted. This one, it is a good observation, right, of the target values, not bad one. So this is the output for normalized target versus normalized LSTAT. Next step is plotting the curve to show how error is decreasing. This is the error versus LSTAT, number of iterations, sorry. From this plot we can see that error is decreasing with increasing iterations, and after certain iterations the plot is nearly parallel. Even if the number of iterations is set very high, it will not cause any more drastic reduction in the error values. Here predicted value of the model we have set. Prediction of prices we have to do. We use this testing data set to observe how well the model performs on the data the model hasn't seen, right? We compute the predicted values of testing data set. We have generated a list of predicted values using line equation here. After that we are calculating mean square error to this parameter to this function are y test predicted, target values and predicted values. After that we are putting x test, y test and predicted values side by side to look at how close the predicted values are to the target values. To do this, construct data frame, this one. Parameter to this are rows which we can generate with zip function. So zipping x test, y test, predicted values will cause each of the values in this list will be placed side by side. So we can see here that output about the predicted values which are close to the target values. Next is reshaping. In reshaping we have one row to one column, passing -1 to one of the arguments of the reshape, so that argument is automatically computed at runtime. So we have reshape here 1 minus 1 and 1. So here extra dimension is added, which is removed by slicing operation. We reshape here, then extra dimension is added. So to remove that, we have to slice it. And here we have inverse transform. So performing inverse transformation here, after transformation there will be one extra dimension in results. So to remove this extra dimension we use slicing operations. Here colon here denotes select all rows, but -1 denotes select only last element of it. Once we have scale data, construct data frame with this one, with placing all three columns side by side and using zip function also. So we can see, we will see predicted prices and actual prices side by side in output. This is the one. So we have this X test, Y test, target values, feature values, target values, and this is the prediction. So this is the final output. Thank you.